Then, yes, okay. Okay. Now we'll continue with it. We saw about the form works. We left till what is striking time or the stripping time. We'll see about this. Striking time is nothing but the time you give for the form work. Minimum time you allow for the form work to just be on the structure. After that only you'll be a minimum duration. That is striking time. The time. 1 minute. I'll go on with the this. Okay. The time to be allowed before form work can be removed naturally depends upon the following factors that we'll be seeing. Type of concrete mix used. Mainly, the main ingredient in the concrete is the type of cement we use. That may be normal, ordinary Portland cement or PPC cement or rapid hardening cement. Mostly, if you use rapid hardening cement, a day or two earlier, you can remove the formwork. Rapid hardening cement mix requires less time, whereas high water cement ratio needs longer time for the striking of formwork. The type of the structural member being cast, soffit of the beams and slabs or sides of the beams or columns require different times. Every structural element requires different striking time. Weather conditions, hydration process accelerates in a hotter weather condition when compared to the cold or the humid weather conditions. These are our structural members. We'll start with the beam, walls, columns, beam sides, walls, columns. For the OPC cement, if you use OPC for either 33, 43 or 53 grade, you require 2 to 3 days your formwork should be on the site. Only then you should remove it. If you go for rapid hardening cement, 2 days is sufficient. Then meanwhile your concrete will be achieving the minimum target strength, so you can remove it. And the next element is a slab. Vertical supports remains intact. For the slab, nothing but the roof of your thing. You need the vertical elements alone to remain. This is for minimum 4 days and rapid cement is for 3 days. The slab, complete formwork removal, it takes 10 days. Complete formwork, like those vertical and the horizontal formwork you will be laying for your slabs. It requires 10 days. For rapid hardening, it requires only 5 days. For the beams, removal of sheeting props remains intact. This is for a minimum 8 days, and for the rapid hardening, it goes for 5 days. Beams and arches, complete formwork removal. That is when the span is less than 6 meter, you shall have it for 14 days. If the span is greater, then you need mostly 90% of the concrete should attain its strength. Only then you can go and remove the formwork. So when the span is greater than 6 meter, we'll wait for 21 days and then remove the beam formworks. For the rapid hardening in the main name itself, you can see the type of cement, it gets hardened very quickly. You'll be seeing those types of cement in your concrete technology. Are you simultaneously going through that?
Yes, ma'am.
Okay. For the rapid hardening, it is 8 to 10 days. For the removal of formwork for the cantilever slabs is nothing but you have extended projection. You don't have a support here. It is only a temporary support. You have an extension. This is the formwork props. Once you remove it, only this is attached to the column. Only this will be hanging. Excess portion will be hanging. That is a cantilever slab. First, free ends should be removed. When this is while concreting, you have given three props, three vertical supports. After the initial duration, you have to remove the free end support. This vertical prop you have to remove. Then later you will be removing the other two. For the simply supported, you have a column here, you have a column here, which means at both the ends it is supported by a column. Only the middle beam is hanging. Beam or the slab is hanging. For this, you will be providing three supports. For example, I'm saying it is three supports. First, you have to remove the support at the mid. You have a support, that one you are removing. Then you will go for the side supports. Then you will remove the side supports. Maintenance for the formwork, due to the continuous use of wooden planks and steel plate surfaces may become uneven and require maintenance. Proper maintenance should be there. once for all, like you purchase or you get a quotation from the supplier for the formwork. They come and just give all those materials for you to the site. You should not just like fix it and just go for concreting. You need to maintain properly. You should make sure that you oil the inner part of the formwork and then use it. Only then your concrete will not be stuck to that surface. You can remove it easily. If you don't apply oil or any greasing material, then your concrete will be stuck to the formwork. It may be either wooden or steel. Your concrete will get stuck to it. Then later, if you hit it again, your structure, the constructed structure will get damaged. Bolt hole places must also be repaired. For steel formwork, plates must be leveled by metal and loose corners must be welded. We'll see the causes of failure for formwork. What are the causes? Improper or inadequate shoring, inadequate bracing of members. If you have a vertical column of three, if you're bracing only at the, like if you're putting only bolts and nuts at the bottom and the top, in between also you do require bolts. Only then your formwork will not open up. If you are providing only at the bottom and the top, you're not providing at the middle, there will be a slight opening where after remove of the formwork, you can see your column will be bulging at the middle, and it will, the top and the bottom, it will be even, the middle alone it will be bulging. Lack of control of rate of concrete placement, improper vibration or consolidation of concrete, and also like once you are pouring the concrete into the column, you are not consolidating it properly, or you have to use a vibrating needle or any type of vibrator that is available. You have to insert it into your concrete, and then you have to vibrate it. If you are not vibrating it properly, you will definitely have some formwork failures. Improper or inadequate connections, improper or inadequate bearing details, premature striping of formwork. If you are in a position, you have to go on with your project very soon. You have to complete it very soon. So you should not rush up in this formwork stripping time. If you rush up, your structure will completely fail. Like you'll be familiar of hearing so many buildings that is getting collapsed. The floor is being collapsed. It for like two or three laborers have been injured. They are spot dead. Those things are due to this premature stripping of formwork. Like they remove it before the concrete attain its strength. Errors in placement of reshoring, improper or lack of design of the formwork, inadequate strength of form material. If it is a wooden thing, if the lifespan of that material is exceeded, or the wear and tear of the by continuous wear and tear, the material doesn't have a proper strength. If you pour concrete, definitely it will open up. The slab will open up and it will fall down. Failure to follow the codes and standards, modifications of vendor supplied equipment, negligence of workers or the supervisors. And we'll be seeing, this topic is not in your syllabus, but we'll be seeing what is concrete curing, and what are the methods to see concrete, like how to cure your concrete. Concrete curing is a process of maintaining the moisture content of concrete till it gets adequate strength. When water is added to the cement, it starts hydrating. This hydration continues till there is a presence of moisture. You will have you have the internal water for the mixing water you have. That water, it reacts with the cement and the cementitious material, and it forms the hydration products. That is how your cement gets hardened. Your water will be getting changed into your hydration products. It will take some minimum 28 days to develop internally, and then your concrete will be getting hardened. The concrete gain its maximum strength in 28 days, so it is required to keep it moist till it gets its maximum strength. In case it loses its moisture before gaining its strength, you will definitely have cracks which will appear on the surface, resulting in failure due to insufficient strength. Proper curing of concrete not only gives sufficient strength but also abrasion resistance, water tightness, and freeze thaw resistance. Those things you'll be studying detail in your concrete technology. We'll see the three major factors. one is the time, one is the temperature, and another one is the moisture. These three things should be properly done. Minimum time you'll be leaving it for 28 days when it goes for your laboratory condition. For your on-site conditions, that 28 days you cannot wait, so you have to initially cure it for minimum 21 days at least. That will give you more than 99% of strength. We'll see about the types of curing. Are you all along with me?
Yes, ma'am.
Yes? Okay,
Yes, ma'am.
thank you. Thank you.
Yes, ma'am.
Wet coverings, leftover formworks, membrane covering,
Yes, ma'am.
ponding, immersion to water, sprinkling, compound curing. These are the types, these are the major types of curing we'll see. First is the wet curing. For the wet covering, what we do is initially we take some jute bags or any jute cloth materials. We'll wrap over the beams, columns, or the walls. That is mostly it is done for the vertical members. You can just wrap it. You can pour water to it. The dampness will be absorbed by that cloth, and it will the surface will be kept moist till the next curing you do. If you do in the morning, you just go water your column, and you wrap it with a wet jute bag. You just water it. Meanwhile, till evening, you can see the wetness. You can feel the wetness existing there. Then again, you can water it. This things continuously. You cannot ask a man to stand there and just water it continuously. So this type of things are followed in the site. And leftover formwork. Formwork act as a covering surface that keeps the moisture from evaporating. Like it prevents the evaporation of the internal materials present, or reduce the rate of hydration. In case of dry weather, these formworks need to be wetted time to time. If it is a very hotter climate, you need to for the next day 24, you'll be removing it by 3 or 4 days. For that, those 2 or 3 days, you can water that formwork also. For watering it for 1 or 2 times, that is not going to damage your formwork completely. And a membrane covering, the use of waterproof membranes such as polythene bags, rubber sheets, waxes, or bituminous emulsions. These are the external layer you apply over your concrete surface in order to prevent the evaporation. This method can be used where there is an inefficient supply of water. Like your site is nearby some dry area, you don't have any proper water supply. You have only sufficient water for your construction, not for your curing purposes. That time you can go for waterproof membranes and slope surfaces, etc. These are the rolling of polythene sheets over the surfaces. And this is ponding. Next type of curing is ponding. Ponding is used on horizontal surfaces such as slabs, pavements, and runways. You might have seen somewhere where, like nearby neighbors who are constructing for the floor curing, the slab curing. What they'll do, they'll make a small bump like over the entire structure. They'll split it into squares. They'll create some bump likes. They'll pour water in order to make it uh, they'll make a pond, temporary pond like thing. They'll store water in it. That will be stored for say 7 to 14 days. Over that, they'll refill water till 21 days. This method requires sufficient supply of water. Ponding is advantageous for large surface area as there is a greater rate of hydration. This one I'm telling. You might have seen this. This is like temporarily, you can either make it of the cement mortar or something. Once it is all done, anyway, you're going to put some dump material over it, and you'll be going on for the next floor level. Like you'll be putting your materials like your tiles, so and so, or mosaic marbles. So this thing, it's not going to affect your structure. Immersion to water. This immersion to water curing type is mainly for your laboratorical purposes. Prior to destructive testing, like you cast your cubes, cylinders, beams, or your beam columns, joints, like you produce everything, you put it inside water. You have a water tank there, you put it in a pool of water, you let it for 28 days, and then you test it. The water in a pool should be clean to get the accurate results. This is a like image I got it from the web. You can see some like if you come to our concrete lab, you can see there are two large tanks of water in which they carry cube cylinders and beams. And this is sprinkling. Water can be mixed on the surface by means of sprinkling, a sprinkler, or manually. You can see a mason holding a hose of water and like he is just wetting the surfaces. That is called sprinkling. Compound curing. Chemicals or admixtures are sprayed on the concrete surfaces to get curing in areas where the temperature is very low. For the very low temperature, when it goes to cooler climates, then we are in a position to go for compound curing. There are ready-made chemicals available, which you can just coat it over, or you can just it's like a type of painting. You can just paint it over the concrete surfaces that will prevent the evaporation process. I'm really sorry. This image, it should not come here. I'm really sorry for that. And slip form. Next topic is slip form. Shall we move to the slip form? Anyone has any doubt? Yes. Are you all along with me? Finally, it should not end up in a tragedy that I am alone looking to my laptop and speaking up. Are you all along with me?
Yes,
Yes,
ma'am.
ma'am.
Okay.
Yes, ma'am.
Thank you. Thank you.
Yes,
Okay.
ma'am.
Yes.
Now, thank
Yes,
you.
ma'am.
Now we
Yes,
will
ma'am.
move on to the slip form. Slip form is nothing but a sliding type of formwork. A formwork which moves usually in a continuous manner during the placing of concrete. If you're going for a multi-storied building, what you will do? For a multi-storied building, you have your G plus 4 or something, you first floor, second floor, third floor, fourth floor, you have like this. So you will initially set a formwork for this, you construct it. Then you will set a formwork for this, you will construct this. Then again you will extend the column, again you will put this roof, again you will go to the next floor column, next floor roof, like this manner you will go. But when it comes to slip form, it is mainly for the industrial purposes. When you have your structure vertically like this, you have your vertically rising formwork. It's nothing but the vertically rising formwork. Initially, you will be doing at the bottom layer. Once your concreting is done, you can just lift it vertically using your power jacks. You can lift it and you can take it to the next sector. Next thing you can take it. Once this is done, concrete is done, it is set for 2 to 3 days. Then you can lift it to the next floor. Like you can lift it. The height of the formwork is designed in such a way that during the pouring of the upper level formwork, the concrete poured in the bottom level should gain its minimum initial setting time. That is, it should attain its target strength. The concrete exposed when the formwork moves up will remain firm. These are usually meant for tall structures. The slip form may be vertical and horizontal. Vertical in cases is go for industrial purposes. You build your towers, so and so things that they'll be using. For horizontal, you'll be going for the laying of roads. Generally, it moves at a rate of 300 mm per hour and shutter height ranges from 1.1 to 1.5 meter. Slip forming relies on the quick setting properties of the concrete, also requires a balance between the quick setting capacity and the workability. You'll be dealing regarding this quick setting and each and every terminologies like workability, vibration, all those things you'll be going in detail in your concrete technology. Concrete needs to be workable enough to be placed in the formwork and consolidated, yet quicker setting enough to emerge. Like once it is done, you can move up. This strength is needed because the freshly set concrete must not only permit the form to slip by the concrete without disturbing it, but it also supports the pressure of the new concrete as well, as it resists collapse caused by the vibration of the compacting machineries. Once your bottom floor is done, bottom column or the walls are done, if you go for the next thing, you should make sure that it has attained its strength. Only then you can go pour your concrete here and you can also vibrate it. These are the examples for the vertical slip. These are the slip form, these things based upon the structure. You design and prepare your slip form working in such that manner. Once you are done with this layer, you lift up to the next layer. Once it is done, you lift up again. This goes on up to the desired height. You will be having a crane over here to lift all the materials there, and working platforms as well will be there. You can have your manpower there to go concrete it. The concrete, it can be pumped through the pumping machines. And this is for the laying of the roads. In one pipe you will be having a concrete to just pour it. This works out only when the surface is level. If you have any undulations like this in your road manner, if your road is like this, then it is tedious to provide perfectionist along the curved thing. If it is going to a continuous straight stretch of road, then this works out well. Let us not go much in detail. These are the working platforms, and then using this jack, you can lift it up. You can see here it is done. Now we are lifting up the formwork. This shows only the single portion, single wall, like only this thing has been shown in detail. Now we are lifting up the formwork here. You are having a plumb bob to check the verticality, whether it is vertical. So again, you can have manpower here. Materials will be dropped here. You can do the concreting. Everything will be done. And these are the explanation of this picture. Those MD terminologies are explained in this. I'll circulate this PPT. You can have a glance of it. This is not that much important. We'll see about the advantages of slip form concreting. You have the next period also. You have it. Our class ends by 12:30.
12:20.
12:20. Okay.
20 ma'am, 12.
Okay, 12:20. You have another class by 12:30?
Yes, ma'am, we have.
Okay. Advantages of slip form is a non-stop method of construction is possible. If you go for normal conventional thing, you have to erect it, again remove the formwork, again you have to place the formwork, remove it. Those types of repetitive types of works are not done here. You are just going to lift the particular thing over the structure. Provide a more working space and safe work environment for the workers, employs less accessory equipments, scaffolding and temporary works, increase flexibility in construction, reduce the labors. The labor cost is reduced because we require only less labor. We don't need labor like if you go for multi-story building, you need labor to fix it, all those things. Here, yeah, the same thing is going to replicate. So moderately skilled labors are sufficient. Uniform wall sections and layouts are obtained. The disadvantages is high cost for initial setup. As we are talking about only for industrial purposes, we can do this. When you are going for a huge construction of a industrial or like factory type of thing, at that time the cost doesn't matter because only depends upon the initial cost. Then if you like simultaneously if you calculate, the labor cost will be getting reduced. Requires specialized workers and expertise, needs sophisticated equipments. You need a hydraulic jack, you need a lift to operate it, you need the lift man to lift those materials and place it in the particular thing, a particular location. Dimensional accuracy can go low in certain conditions. Next will be, as of now, we have completed all the topics. Only one topic left. There is the concrete or hollow block masonry. I didn't take it simultaneously with the brick masonry because it will be little confusing for you to have it huge in brick masonry, while you will be seeing only few parts here. Have you seen this type of block works going on nearby areas, or have you crossed across this type of masonry buildings?
Yes, ma'am.
Yes. Okay. These are the concrete blocks, either hollow or solid. This is a solid. It is similar to that of a brick, so it is solid. A hollow unit is that a unit which has core void greater than 25% of the gross area. That may be used for both load bearing as well as non-load bearing walls. These are the types of hollow block areas. It depends, like you can go with whichever material you're comfortable with. It depends upon the structure. If you're going for single or individual houses, that is you can go for either two type. If you're going for multi-story buildings, you can go for three hollowed blocks. I actually have a video for you. So, Okay. Did you see this video?
Yes, ma'am.
Okay, this type of hollow blocks, they do constructed it. They have only two type of hollow blocks. This they'll be constructing it for the shorter span. If the span of the building is increasing, then they'll go for reinforcing bars like this. They'll just insert it. Mostly it is suitable for both not non-load bearing and load bearing walls. For if you go for load bearing walls, you need to place a reinforcement from the foundation. Then and there you will be inserting this hollow blocks. And let's see the manufacturing process. For the cement is to aggregate ratio, you should follow 1:6. 1 parts of cement is to 6 parts of aggregates. The aggregate consists of 60% of fine aggregates, that is going to be your sand or your M sand, so and so. And for the 40% it is going to be your gravels, that is your coarse aggregates, nothing but the crushed rock materials. You're going to mix it, then you're going to fill it in the mold, you're going to compact it, and using vibrating in order to you are going to vibrate it using a vibrating tools or the table vibrator in order to avoid the voids present. And you will cure it for the minimum period, and then your block is ready for use. You can transport it to your site and you can use it. The properties are the sizes are 39 centimeter cross 19 centimeter cross 30 centimeter. It comes in three different sizes. You can choose depending upon your, the building, the type of building you go for. If the span is length, if the wall span is length, lesser, you can go for 10 centimeter, or you are going to construct it for industrial purpose, you can go for huge size of 30 centimeter. Density is solid concrete blocks are 1500 to 2000 kg per meter cube, whereas hollow concrete blocks they are 1000 to 1500 kg per meter cube. Almost it is one by half. And compressive strength, solid concrete blocks they are greater than 5 Newton per mm squared, whereas hollow blocks they range from 2 to 4 Newton per mm squared. Water absorption it is less than 10 to 15 percentage by weight of the block. The main advantages is it is the type of building you construct using hollow blocks or the hollow cement blocks or the solid blocks. Like this is quite less time consuming. The cost you will be by time more or less it has been brought into market. Like many people are using it, so it is getting so much of exposure. The cost is more or less equal when you compare with this and normal conventional bricks as well as this. No dressing work is required. Once you are done with the mortar, you saw in that video the mason is just placing the mortar to the sides of the hollow block, and he is just placing in the vertical, the horizontal manner. Again, he'll be going for the next layer. When he is doing like this, it looks very good when you are seeing from the outer side. Your horizontal courses are going to be gray in color, as well as your cement mortar is also in the same color. So definitely you'll be having a uniform color. So you no need to go for the next, over dressing of the works are not required there. Not much skills are required. They are structurally strong than bricks. Thinner walls are quite possible, hence giving more carpet area. Carpet area is the living area, the built up area inside your building. Large in size, hence number of joints are less. It saves mortar when compared to bricks. As your brick size are less, they require more mortar to place it along your sides as well as on the top and the bottom. So you can save the mortar. Best insulating material against heat, sound and dampness. Not needed to require plastering works. Next is cavity walls. This is also a part of this first unit. We'll see what is cavity walls. Cavity wall is nothing but you construct two parallel walls. You construct a wall here as well as a wall here, providing a air gap or a air cavity in between it. You connect this two vertical members using metal ties. We'll see it. It is a wall consists of two parallel walls separated by a continuous air cavity, or it is interconnected using ties at regular intervals. The outer wall is called the outer leaf and the internal wall is called the inner leaf. In the structural term, they call it as outer leaf and inner leaf. It is usually outer leaf is thinner than the inner leaf. The construction procedure, One minute. Actually, this is the cavity wall. We have a wall here as well as a wall here. Both are in the same pattern. Here is a metal ties. You have a metal type. It will be usually it will be in this type. One will be embedded in this wall and one will be embedded in this wall. This is one wall as well as this is one wall. Sorry. Okay. It is constructed in two leaves, inner and outer, with a hollow space in between. The width of the cavity is constant with a suitable value ranging from 40 to 100 mm. Cavity is a continuous in vertical direction except at lintels and opening. That is, when you place your doors or your windows, there will be definitely another layer called DPC, damp proof course layer will be laid, which will connect both your both your walls. It will be connecting both your walls. There alone, this continuity will be break. And the inner and the outer walls are interconnected by means of metal ties or bonding bricks. The bottom of the cavity wall should be well ventilated by the use of air bricks and ducts. The metal ties are generally wrought iron or mild steel bars. They are connected with a hot tar or they're using the galvanized material to prevent corrosion. You can see there is a minimum of 2 inches minimum cavity. You should have minimum of 40 to 100 as we saw in the IS standards. For non-load bearing cavity wall, two leaves, that is the two walls, are of equal thickness, or sometimes internal leaf with more thickness is provided. The cavity size should be between 4 to 10 centimeter. The internal and the external should have at least 10 mm thickness. The two leaves are interconnected by metal ties. By constructing a cavity wall does not require any footing under it. A general concrete footing is more sufficient for a over this concrete footing. You can go for a direct cavity wall construction. Then a strong concrete base is provided on which a cavity is constructed centrally. You take a mid of it, you plan it accordingly. You provide one here and the one here with a minimum gap here. Two leaves are constructed like normal masonry, but minimum cavity must be provided in between them. The cavity walls is filled with lean concrete with a small slope at the top up to few centimeters above the ground level. This is your concrete flooring foundation. Over that, this is your one brick, and this is your one brick wall, and this is another brick wall. You have the concrete here. You can fill it in a slopy manner. You can just fill it in order you should have some bond in between these three composite materials. This is a brick wall, again this is a concrete wall. You need some bond between all the three. That's the reason you provide lean concrete here. And you have your concrete flooring here. It is enough if you just pour this concrete up to the ground level. This is the soil ground level, you have it. Up to this, if you pour your concrete, that is more sufficient. The cavity wall must start from the top of the foundation concrete, extending up to 150 mm below the DPC. Here you're going, this dark color black line is nothing but your DPC. That is nothing but damp proof course. Damp proof course is, it is, do you know what is damp proof course? Yes. Are you all there? Or you just logged into the meeting and just okay. I'll tell you what is a dam proof course. It is nothing but a barrier which is designed to prevent the dampness. You have the soil here. It should not penetrate the water through any manner. It should not penetrate the water to your structure. Okay. For that reason, you are providing the dam proof course here. It is nothing but it exists above the ground level. It exists between the ground level and the floor level. This does exist. Okay, that is the dam proof course. And for the construction of top of the wall, now this is a continuous wall. You are done with this. This is extending. I'm sorry. Now you are at the top portion of your building. This is your slab or your roof. You have it. Again, it is getting connected using again dam proof course. Okay, this layer is it is connecting both the walls. You can see wall tiles, I mean ties, you have the metal ties, those ties can be used here. And this is final copying is done. You know what is copying? Copying is nothing but the topmost surface, either it can be brickwork or concrete work, it is done at the top of your structure. Usually your if this is your floor level, I mean roof level, then this is going to be a parapet wall. For the parapet wall, you have this holding at the top. If you go to your terrace, you will find a wall extending up to your hip level. That is nothing but the parapet wall. Your foot will be here, your hip will be here, which means this is the parapet wall. You will have the copying here. So you're at this position, this is going to get connected into the internal wall of the structure. Cavity is provided up to the top of the parapet wall of the terrace and covered with a DPC. Here below the copying also you provide a DPC, a block of parapet on terrace. Dropping of mortar is prevented by covering the cavity by a wooden batten. That is nothing but the mason will be having a rectangular type of wooden tool just to plaster it. This type of wooden plate or the board is kept in between both the thing in order that mortar should not fall inside. You have to maintain that cavity. The advantages of this is moisture content in outside atmosphere will not be entering into the inner thing. You have one block here, one block here. This outside may penetrate into it, but you already have an air gap as well as a brick. So it will not definitely, either it is a hot or the cold climate, this will not penetrate through the second wall. The heat insulation improves by around 25%. Good insulation against sound, cheaper and economical. Efflorescence reduces. And next is the glass block masonry. Okay, I have few minutes. This is nothing. These are the different types of glass block masonries. I think you might have seen this glass block masonry, this type of glass cubes stuck in the many restaurants. Like they'll be having it as just a small partition. You'll be having a room here. They're going to just give a small partition using this glass masonry where they'll be having one table here, one table. To improvise the privacy, they might have been constructed like this. These are the different types. This is clear, brompo, bubble, diamond, ice cube. Mostly these are the different types. You don't need to study all these types. You just know what is glass masonry. They'll be just applying the mortar over it. They'll fix it. Finally, this white color, like it may be like the insulating material, they can provide it to just avoid the air gaps between the one other material. Here you can see it is little indented at the mid. So this location, they can provide the mortar. They'll provide the mortar in the middle area and this will go in contact with the above. Like it will be like this. Here, this bumpy region, they'll be applying the mortar. And these are the types which I told. Mostly for the residential purposes, this goes quite costlier. So we do avoid this. It's better for us to go for brick masonry or hollow blocks. We are done with it. You have any other doubt? You have any other doubt? We are done with it.